This is day 38 for solving problem of the day from GFG. Let's look at today's problem. Okay, so given two linked list n and m, write a program to get the point of intersection. Okay, so let's understand the problem with this example. So I hope you know intersection. So intersection happens between two things. Okay, so suppose this is a straight line, here is a straight line. So this is the intersection point. Okay, now here we are not working with straight lines. Okay, here we have nodes and linked list. So this is a linked list. Okay, 3, 6, 9, 15 and 30, and here we have another linked list 10, 15, 30. Okay, so here two linked list actually intersects. Okay, this is a linked list. Let me do this by this, I think. Yeah, this one. So this is a linked list and it is intersected with this linked list. Okay, so these are the two linked lists. Separately they both of them intersects. So what we have to find is we have to find this intersection point, which is 15 here. Now note one thing, that we don't have to so you see that they have common part, right? If they intersect, they must have a common part. They are not straight lines, so they have a common part as a list, which is 15, 30. This is not a straight line, it should not have a common part as a point, right? So in case of linked list, the intersection will give you a common linked list. Okay, so in linked list, if you have an intersection, you will get a common linked list. So this is the common linked list 50, 30. Okay, so, and the common point from which this common point is starting, actually common point, that is the first point where they meet. Okay, the first point where they meet, that is we have to return, which is 15. But note one thing, that by saying the common point, we are not meaning to say the common value. Okay, we are saying the common reference. All right, we are comparing the linked list on the basis of reference, not on the basis of values. Okay, why? Because suppose here is a linked list 1, 2, 3, 4, 5. Here is a linked list 2, 3, 4, 5. Okay, so 2 is a node, right? 2 has a node in which the value is 2. So by writing this 2, it is actually a node which have a 2 value and a point reference value which is pointing to another node having 3 as a value, and a reference value which is pointing to 4, which is a value, which is a node value, and a reference which is pointing to 5, which is a node value, and a reference value which is pointing to null. And here is a, so here is our 1, and here is another. So by reference, this is the address of a node, right? So the address of this 2 is not same as the address of this 2. Okay, so this 2 has another address. Okay, so this is the node which is pointing to 4. So the address of it may be 1001 and this is suppose 2001. It is different, not same. The same you will get is here. So 2, 3, 2, 3, 4, 5 and 1, 2, 3, 4, 5. there are two linked lists that is given to us, linked list 1, linked list 2. So this node and this node have the same reference. Okay, so this node has same address as this node has same address as this node, but these values are same, but they are having different references. That's why we are saying that 4 is the common point, not 2. Okay, here you can see that 4 is our common point. Okay, so 4 is our common point, not 2. Why? Because in linked list 1 4 and in linked list 2 4, they are having same reference. Similarly, after that, starting from 4, all the list values, all the list nodes have the same reference. Okay, so that is, you have to understand that two linked lists must have same values starting from anywhere, but that may not be the common point for them. Okay, we have to check the reference, if this reference is equal to this reference or not, this reference is equal to this reference or not, this reference is equal to this linked list reference or not. If it is, then this is the common point. Okay, so the solution is actually very easy. The problem is medium, but the solution is very easy. Okay. So let's look at the solution. So what we are gonna do is, so we have these two lists. Okay. 3, 6, 9, 15, 30, and 10, 15, 30. So first we are gonna store these nodes, not the values. Okay, so not the nodes. We are gonna create two array lists first. Okay, we are gonna create two array lists, one for the first linked list and one for the second linked list. What they are gonna store? What they are gonna store? They are not gonna store the values. Okay, it must, this node, this is actually a node having 3 as a value, so this whole node must have a reference, that is address. So that address it will store. So in array list 1 I will have address of 3. Okay, address of 3, I am writing like this. Here I will have address of 6, address of then 9, address of 15, and address of 30. Here I will have address of 10, that is reference of 15. Not so address is not a suitable word for here, as we are using Java. So think it is as a reference. So we will store the references. Okay, then we will start from the last value. We will start from the last value in the array list. If these two references are same, just go to the previous value. If these two references are same, just go to the previous value. Now these two references are not same. This is a 9's address, this is 10's address, right? So they are not same. They are having different values, so they must be different reference, right? If they have different values, they must be different nodes, because one node can store only one value here. But if they have same value, they may or may not have different reference. Okay, but if they have different values, they must have different nodes. But if they have same value, they may or may not have different nodes. Okay, so here we got different reference. Okay, so they are belonging to different nodes. So here we will stop the loop, and what we will do, we will calculate the just after value of this. Okay, so the value after this, we will take that, the value after this, which is this, we will take that, and That will be our answer, right? That will be our answer, because this is the first point. We are checking from last, right? We are checking from last. So this is the, suppose two array list have three common points, common reference. After that they have different reference. So we are starting from last. They have same reference, go for the previous value. They have the same reference, go for the previous value. They have the same reference, go for the previous value. They have different reference, go to the next value, that is this value. So these two have same reference. So this is the first point. This is the first point of our common array list, and that is what we have to find, right? I think you have understood the point. If they have the same reference, okay, which is the first of all the references which are same. Okay, so 4 5 is the list of common reference, or you can think it as a linked list, and 4 is the first point. So 4 is actually our first common reference. So what we will do then, we will just return the value corresponding to this reference, which is 15, right? So we are going to return 15. So that is the point. So what we are going to do, let's just revise the thing. Suppose we have two linked list, 1 2 3 4 5, like this, and another suppose 10 24 5. Let me write like this, 4 5, and we have to so yeah. So what we are going to do, we are going to create two array list where we will store the reference corresponding to their values, right? And we will keep searching from the last. If they are of same reference, go to the previous. If they are of same reference, go to the previous. If they are of same reference, go to the previous. If not, go to the next and return the corresponding value. Okay, so that is the basic algorithm. You will understand the thing fully now. Okay, so just create two array list of node. So we are storing reference, right? So reference means node here. Node is equivalent to reference, because so reference is itself the node, right? For example, next is the reference, right? And next is of type what? Node. Okay. So the reference type we have to give here, and the reference type is node. That is why I am writing here node. If I am storing integer value, I would like to store integer here, because integer values are of integer type, right? That if we are storing reference, and the references are of type node. That is why I am writing here node. Okay, that's fine. Now just create two traversing reference, which will just traverse and give me the references. Okay, so while temp1 not equal to null, or temp, so just look for this. So while temp1 not equal to null, just add the reference temp1 and do temp1 equal to temp1 dot next. Similarly for the second list, Then what we're gonna do, start from last, that is add a list size -1, and while my I and j are non-negative, if my references are same, okay, if my references are same, so just go to the previous value, previous reference. Otherwise we will break it and go to the next reference. That is our answer. Now it may possible that the loop actually terminates by the condition of I less than 0 or j less than 0, right? So you have to check that. If I is greater or equal to 0 and j is greater or equal to 0, that means that everything is okay. All right. So if the loop does not terminates on the condition of this, that means we found some reference which is not same. That is how the loop should terminate, by this break condition. So then we will just go to the next reference and just return the just return the answer, that is the value corresponding to that reference. Okay. Now if the loop actually terminates, so that means that two linked lists have same references along all the values. Okay, so all the values of the two linked list have same references. Okay, is that what they mean? Yeah. So that means the two linked list is actually same, so they do not have an intersection point. If all the references are same of two linked list, they do not have an intersection point, right? They are same, so we'll return -1 in that case. I hope this works. Let's run this. Compiler error, that's good. 172. Yeah. Choose anyone, at least one or two. That doesn't bother anything. Okay, so greater equal to 0 and greater equal to 0. Okay, so here this will be added to at least 2, right? Okay, so now it runs. Now let's submit this. I hope this works. Okay, so we got it. So I hope you like the video, and if you do, then do like, share and subscribe. See you in the next video.